Hello guys, today we will work on the triangle, of course the right triangle, and what we'll be looking for is the measure of every single angle in the triangle and also the length of each side of the triangle. My notes are slightly different than yours because I went ahead and drew a triangle for every single problem rather than use the same triangle for the first three problems. On problem number one, I am told that the side B, lowercase b, which is this side, is 5. This remain A. I have C here and B here. So apparently this side is 5, and the measure of angle B, which is this angle, is 38 degrees. In other words, I only have two sides missing and one angle missing. The easiest thing to find is the angle because I know that the sum of all angles in a triangle is equal to 180. So to find the missing side, I will only do the missing angle. I will only do 180 degrees. That I will subtract 90 degrees, which is my right angle. And I will also subtract 38 degrees. And if you complete this operation, you should end up with 52 degrees as the measure of angle A. That's the first information we can find. The measure of angle A is equal to 52 degrees. I suggest that you don't use this angle to find any of the side because if you do and you get this angle wrong, that will affect your whole problem. So let's go ahead and now find lowercase c. To find c, all I know is this angle. I know this side is 5 and c is the hypotenuse. The only trig function that connects this angle with the opposite of the angle and the hypotenuse is the sine function. So I recited the sine of 38 degrees in this specific triangle is equal to 5 over the hypotenuse, which is c. If you reorganize this, you will end up with, it will lead you to c is equal to 5 over the sine of 38 degrees. According to what was asked here, I'm looking for all sides to be rounded to the nearest thousand and all angle measured to be rounded to the nearest degree. So I will go ahead and use my calculator on this. If you use your calculator, this is the first answer that I have so far on my calculator. 5 divided by the sine of 38. Make sure your calculator is in degree. 5 divided by the sine of 38 is 8.121. So here I will make sure I write approximately equal to 8.121. So as of right now, I have this side, I have this side. I'm missing this side, but I do have the angle already. So to find the last one, I will say the only operation that links the 5 that I know, which is the opposite, and A, that which is the adjacent of the angle 38, is the tangent. So I will say the tangent of 38 degrees in this specific triangle is equal to 5 over A. So if you reorganize or you organize this expression, you will get A is equal to 5 over the tangent of 38 degrees. Using your calculator again, you should get 5 divided by the tangent of 38 degrees is 6.400. So here you will write approximately equal to 6.400. Let's do the same thing for 2 and 3. Once again, I drew my triangles already. You can draw your own, and I actually suggest you draw your own instead of using the same triangle for all three problems. Once again, this is A, this is B, and this is C. I know this is a 90-degree angle. According to what's given, this side is equal to 4. This side C is equal to maybe I label it wrong. Let's put B here, and instead of B here, I want you to write C. So this is C. Therefore, C will be this one, and I call this one 15. Now, knowing that this is 4 and this is 15, 15 being the hypotenuse, using your Pythagorean theorem, you can find the missing side, which is side, I'll call this side B. B is therefore equal to, once again, that's using your Pythagorean theorem, the square root of 15 squared minus 4 squared. Using your calculator, square root of 15 squared minus 4 squared is approximately equal to 14.457. Double check my calculation here, but this is the first answer. Once you complete with this, let's go ahead and try to figure out the measure of this angle. I will call that angle theta, or you can call it angle B. So let's call it angle B to make it easier. I would say the measure, or what trig function is connecting this side and this side, and of course the angle B. The only trig function that connects the adjacent to the hypotenuse is the cosine. So the cosine of angle B is equal to adjacent, which is 4/15. Now, based on your previous notes, if you're looking for an angle, you must apply what we call the inverse trig function. So I will say measure of angle B is equal to the cosine inverse of 4/15. Using your calculator, you will get the value for the cosine inverse of 4/15. Why don't we do it? All I need to do is cosine inverse of 4/15, and the answer seems to be 74.534. But since we're rounding our answers to the nearest thousand, actually since it's a degree value, to the nearest degree, instead of 74.533 or 534, I will say 75. So this is approximately equal to 75 degrees as a measure of angle B. Now that we have the measure of angle B, if B is 75, this is 90, the sum of all angles in the triangle is 180. So all I need to do is 180 minus 75 minus 90, and I should get the measure of angle A, and that would be 15. So the measure of angle A is equal to 15 degrees. Let's look at the last one. Unfortunately, the space is not good enough for us to use, so I might let you do this one by yourself, but I will start it. Measure of angle A, which is this angle, is 24. I'm putting a line here just to separate it. Measure of angle A is 24. We have C is 23.6. Knowing that this is C and this is B, the first thing you can look for is the measure of angle B, which is equal to, using your the fact that the sum of all angles in the triangle is equal to 180, you will understand that B is equal to 76 degrees. From here, you cannot use the Pythagorean theorem because you're missing two sides. Instead, I can use, let's call this one for now lowercase a. If I'm looking for a trig function that connects the hypotenuse to this lowercase a, which is the opposite of 24, I will therefore use the sine of 24 degrees is equal to, and I will say its opposite, which is a, over the hypotenuse, which is 23.6. Now, is this the only way? Not at all, because you can also use the 76 that you have here, and instead of using the sine, you can say it's the cosine of 76. It's 100% up to you. Now, I will continue with what I started. To find a here, I will say a is equal to 23 0.6 times the sine of 24 degrees, which is approximately equals to 9.599. Now from here, although I prefer that you don't use the Pythagorean theorem to find the last portion, you can use it. However, the best way to find the last side, which is this side that I will call B, you will use again, let's say the sine of 76 degrees is equal to the opposite, which is B, over the hypotenuse, which is 23.6. If you cross multiply again, you will get B is equal to 23.6 times the sine of 76, and it's approximately equal to, here you will get 22.899. Check my calculation. Use your calculator to find these answers. Now let's get to some few word problems. Once again, I drew my triangle already. You can still draw your own triangle. Here we're looking for, we have a ladder that is 20 foot. We have the distance from the bottom of the ladder to the base, meaning this distance is apparently 5. And what we're looking for, first thing we'll be looking for is this angle, because we say if the ladder is in this proportion, what angle does it make with the ground? So this is the ground, we're looking for this angle. Let's call that angle theta for now. The arbitrary function connecting this theta to the 5 and the 20 seems to be the cosine. So I will say cosine of theta is equal to adjacent over hypotenuse, which is the same thing as 1/4. But unfortunately, we're looking for the angle, so we cannot just use a regular trig function. We will say cosine inverse of 1/4 will give us the measure of angle theta. Or I will just call it theta because we know that's the angle. So this will give us theta. Using your calculator, you will end up with theta is approximately equal to 75.522, which will be round to 76 degrees. After finding the angle, how high up the wall will the ladder reach? This is a very simple one, because if we're looking for this height, all I need to say is the height is equal to the square root of, using Pythagorean theorem, I will say 20 squared minus 5 squared. And this is approximately equal to 19.365. Note that I'm rounding all sides, all lengths to the nearest thousand, and every single angle is rounded to the nearest degree, meaning nearest whole number. The unit here should be in feet. The next concept for you to know is that we have two types of angles that are very important. One of them is called the angle of elevation. The other one is the angle of depression. Now, the angle of elevation and the angle of depression are always formed with the horizontal line. What do we mean by that? If I have this as my, let's say angle, let's say this is my angle, I would call this one depression because it's from the top going down, and this one is called elevation. There's one very good concept by these two angles. If you remember in geometry, whenever you have two parallel lines, these two angles are congruent, but they have a specific name. So what is significant about the angles of the angle of elevation and angle of depression is the fact that they are congruent. And why are they congruent? This is when you need to remember your geometry. They are congruent. By the way, this symbol means congruent, but let's just write congruent for now. Now, why are they congruent? These angles are nothing other than alternate interior angle. Remember, it says we said in geometry that alternate interior angles are always congruent. Now, knowing that they are alternate interior and that they are always congruent, let's try to see if we will be able to answer with number 5 and number 6. On number 5, it says the flagpole casts a 60-foot shadow. I'm assuming that this is the shadow, and of course the shadow is on the ground. When the angle of elevation of the sun is 35, this is therefore the angle of elevation, 35. Please excuse the bell. Now, knowing that the angle of elevation is 35, by the way, what's wrong with this? The angle of elevation and angle of depression is always with the horizontal. So this is my 35. Now I bet you can solve the problem. Knowing that this is 60 and this is 35 degrees, we're looking for the height. So I will use the sine of 35 degrees is equal to height over the hypotenuse. Can the sine help me here? Obviously no, because I do not have the hypotenuse. So instead of the sine, I will go ahead and use the tangent, because the tangent is the only one that connects this 60 to this h. So I will say h over 60. So the height itself is equal to 60 tangent 35. And 60 tangent 35 is exactly 42, actually approximately 42.012 feet.